Another category is going to be that of the height of a projectile. They're giving us an equation. H is equal to negative 16t squared plus 256. A stone's being dropped from a 256-foot height. That's the 256 in the equation. It's being dropped. There's no initial velocity. T is time in seconds. When will it hit the ground? When it hits the ground, its height is 0. So there's what we've got here. I'm going to factor the negative 16 out on the right, which gives me t squared minus 16. I'm now going to factor the difference of two squares, giving us t plus 4 times t minus 4. So t equals negative 4 seconds, which doesn't make sense, or t equals 4 seconds. That'll be when it hits the ground. It can't hit the ground 4 seconds before we drop it, and that's why that negative solution doesn't work. A fifth category of these problems. Here's another problem, the Pythagorean theorem. We know that we're going to take the sum of the squares of the lengths of the legs, x squared plus 8 squared, and that's going to equal 10 squared on the right. X squared plus 64 will equal the square of the hypotenuse 100. I'm going to subtract the 100 off of each side, giving me x squared minus 36 equals 0. And that will then factor the difference of two squares. X plus 6 times x minus 6 equals 0. X cannot equal negative 6 in this case, just due to the geometry of the nature of this problem, and so x is going to equal 6. There's no units in this problem, so we'll just say 6 units will be the length of the side of that triangle. The longer leg of a right triangle, okay, I better draw a picture here. The longer leg, that's the one I've got drawn here as the base, is 1 less than twice the shorter. The long one is in terms of the shorter one. So the shorter one I'm going to make x. The longer leg is 1 less than twice. So 2x minus 1. The hypotenuse, that's the one I've not labeled yet, is 1 centimeter more than twice. 2x plus 1. Okay, there's my setup. Again, we're going to use the Pythagorean theorem. So, x squared plus the quantity 2x minus 1 getting squared equals the square of the hypotenuse, 2x plus 1 quantity squared. We're going to have two FOIL problems within this problem. We're going to rewrite this as 2x minus 1 times 2x minus 1. And on the right, we're going to have 2x plus 1 times 2x plus 1. Okay, here we go. I better move that to the left a little bit. On the left here, we've got x squared plus first term of FOIL, 4x squared. Outer is minus 2x, inner is minus 2x, last term is plus 1. On the right, we're going to have 4x squared plus 2x plus 2x plus 1. Lot of algebra. This is probably the longest equation you've yet solved here. On the left, I've got some like terms to combine as I do on the right. So the left side becomes 5x squared minus 4x plus 1. The right side becomes 4x squared plus 4x plus 1. Because this is a quadratic equation, it needs to be set equal to 0. I've got more x squareds on the left, so I'm going to subtract everything off of the right. Minus 4x squared on the left, minus 4x on the left, and minus 1 on the left. And that's going to give us x squared minus 8x, the ones cancel, equals 0. Factor this into x times x minus 8 equals 0. So x equals 0 or 8. We can't have 0 for the side of a triangle. So going back up to the picture, one leg is going to be 8. The other leg will be one less than twice it, so twice the 8 is 16, one less than that is 15. Then twice the 8 is 16 plus 1 gives us 17. And if you check with the Pythagorean theorem, this is going to work. 8 squared plus 15 squared equals 17 squared. That does work. 64 plus 225 does make 289, and this problem checks.